According to the National Electrical Code, electrical conduits should be connected using threaded fittings. Screw-type fittings are not allowed for connecting conduits. NEC Section 352.50. C states conduit bodies shall be provided with threaded or hubbed connections for entrance of conduits. Section 352.50. H further specifies conduit bodies shall be securely and rigidly fastened in place to provide a secure connection between conduits and the enclosure. Screw-type fittings do not provide a secure and rigid connection, as they can loosen over time due to vibration or other factors. This can compromise the integrity of the electrical system and pose a safety hazard. It's crucial to understand the specific requirements outlined in the National Electrical Code, or NEC, to ensure electrical installations are safe and compliant. Let's delve into the relevant sections of the NEC and elaborate on why screw-type fittings are a point of concern. Firstly, NEC Section 352.50. C clearly mandates that conduit bodies must be equipped with threaded or hubbed connections for the entry of conduits. This requirement is not arbitrary. Threaded connections, when properly installed, offer a mechanically robust and electrically sound connection. The threads engage with each other, creating a tight bond that resists loosening due to vibration, thermal expansion and contraction, or accidental physical stress. Hubbed connections, often found on larger conduit bodies or those intended for wet locations, provide a similar level of secure attachment, often incorporating a gasket or sealant to maintain a watertight seal. Secondly, NEC Section 352.50. H reinforces the importance of secure and rigid fastening. This section doesn't just apply to conduit bodies but to the entire conduit system. The goal is to create a continuous, mechanically strong pathway for the electrical conductors. A loose or poorly supported conduit system can lead to a host of problems, including stress on conductors, potential damage to insulation, and even complete system failure. Now, let's examine why screw-type fittings fall short of these requirements. The term screw-type fitting can refer to various designs, but in the context of connecting conduit to conduit body, it typically implies a fitting that relies on one or more screws to clamp the conduit in place. These screws might tighten directly against the conduit surface, or they might engage with a separate clamping mechanism. The fundamental weakness of screw-type fittings lies in their susceptibility to loosening. Unlike threaded connections, which create a continuous interlocking bond, screw-type fittings rely on friction and clamping force. Over time, these forces can diminish due to several factors. Firstly, vibration is a common culprit. Electrical systems are often located in environments where vibration is present, whether from nearby machinery, traffic, or even the normal operation of electrical equipment. This vibration can cause the screws to gradually loosen, reducing the clamping force and potentially allowing the conduit to slip. Secondly, thermal expansion and contraction can also play a role. As the temperature of the conduit system changes, the metal expands and contracts. This movement can exert stress on the screw-type fittings, further contributing to loosening. Thirdly, corrosion can compromise the integrity of screw-type fittings. If the fittings are exposed to moisture or corrosive substances, the screws and clamping mechanism can corrode, weakening their ability to maintain a secure connection. The consequences of a loose or failed conduit connection can be significant. Firstly, a loose connection can create a point of high resistance in the grounding pathway. In the event of a ground fault, this high resistance can impede the flow of fault current back to the source, potentially delaying the operation of overcurrent protective devices such as circuit breakers or fuses. This delay can increase the risk of electrical shock or fire. Secondly, a loose connection can allow moisture or contaminants to enter the conduit system. This can lead to corrosion of the conductor's insulation breakdown and ultimately, electrical failure. Thirdly, a loose conduit system can create a physical hazard. If the conduit becomes dislodged or unsupported, it can pose a tripping hazard or even fall, causing injury or damage. To ensure code compliance and electrical safety, it's essential to use only approved fittings for connecting conduits. Threaded fittings, compression fittings, and hubbed fittings are all acceptable options, provided they are listed for the specific type and size of conduit being used. When installing threaded fittings, it's crucial to apply a suitable thread sealant or lubricant to ensure a tight, watertight connection. The thread should be fully engaged, and the fitting should be tightened to the manufacturer's recommended torque. When using compression fittings, it's important to follow the manufacturer's instructions carefully. The conduit should be properly prepared, and the fitting should be tightened to the specified torque. Over-tightening can damage the fitting or the conduit, while under-tightening can result in a loose connection. Hub connection should be installed with the appropriate gasket or sealant to maintain a watertight seal. The hub should be securely fastened to the conduit body or enclosure. In addition to using approved fittings, it's also important to properly support the conduit system. Conduit should be supported at regular intervals, as specified in the NEC, to prevent sagging or movement. Support should be securely fastened to the building structure and should be designed to withstand the weight of the conduit and its contents. Regular inspections are also essential for maintaining the integrity of the conduit system. During inspections, look for signs of loose fittings, corrosion, or physical damage. Any problems should be addressed promptly to prevent further deterioration and potential safety hazards. In summary, the use of screw-type fittings to connect conduit to a conduit body is generally not code compliant due to their susceptibility to loosening and their failure to provide a secure and rigid connection. Adhering to the NEC requirements for threaded or hubbed connections, along with proper installation and maintenance practices, is crucial for ensuring the safety and reliability of electrical systems. Always consult the latest edition of the NEC and any applicable local codes for specific requirements and guidelines. For example, let's consider a scenario where a screw-type fitting is used to connect a section of electrical metallic tubing, or IMT, to a conduit body on a rooftop. The rooftop environment exposes the fitting to extreme temperature variations, ultraviolet radiation, and potentially corrosive elements such as salt spray or rainwater. Over time, these environmental factors can degrade the screw-type fitting, leading to loosening and corrosion. The vibrations from wind and nearby equipment can further exacerbate the problem. Eventually, the connection may become so loose that it compromises the grounding pathway, allowing moisture to enter the conduit system and potentially creating a shock hazard. In contrast, a properly installed threaded fitting with a suitable thread sealant would provide a much more robust and reliable connection in this harsh environment. The threaded connection would resist loosening due to vibration and thermal expansion, and the sealant would prevent moisture from entering the conduit system. Similarly, a hubbed connection with a gasketed seal would offer even greater protection against the elements. By understanding the principles behind the NEC requirements and the limitations of different types of fittings, electrical professionals can make informed decisions that prioritize safety and ensure long-term system performance. Remember that the NEC is not just a set of rules, it's a collection of best practices developed over many years to prevent electrical hazards. Following these practices is essential for protecting lives and property. Therefore, it is incorrect to use screw-type fittings for connecting electrical conduits to conduit bodies, and the installer should revisit NEC Section 352.50. See in Section 352.50. H.